Hi everyone. Today we'll be talking about functional safety. I'm Jurata Białek. I'm working for GlobalLogic in Kraków in Poland. And I work as the analyst. In our industry, it's rather requirement engineer. And this is the project I'm working in is the huge automotive system for the new generation of electric cars. And I want to introduce you to the functional safety topic today and somehow prove to you that this topic is really important. Okay, so before we even start, I want to tell you a bit, a few words why this topic is arising more and more in the industry. Then we will compare the safety and security definitions because I realize that they are sometimes misunderstood or they're used interchangeably. Later, I'll tell you a bit about types of safety that we are encountering in the automotive industry. There will be a part about ASIL standard, together with ASIL, ASPICE, SOTIF terms. And also I want to just emphasize one thing that this webinar is just a short introduction to functional safety and ISO matters because normally the good companies which are providing workshops and trainings, their introductory trainings take at least 20 hours or 40 hours together, and this may be only one part of introduction to functional safety. So our 1 hour today is a small highlight of the most common terms and the information that I was trying to figure out when I was starting to have an interest in this topic. Okay, so why am I giving this presentation at all? Why do we discuss safety matters so intensively? So I don't want to be say obvious things, but there are many factors that are influencing the automotive business right now. So let's take a closer look. I've checked the forecasts and data that there's the big consultancy company called KPMG's. They put together and called Global Automotive Executive Survey. And since 20 years now, they release it every year. These surveys are a great source of information about the industry, like how the goals, priorities, or customers' demands are changing within the years. So I also put the link to these surveys in the end of presentation, so you can take a look when you have a chance. And they asked many hundreds of executives and producers in the automotive sectors, together with government representatives, financial services providers that are involved, and more. And according to these reports, the global forces that are shaping our current automotive sector in the recent years are environmental challenges, digitalization, globalization, growing urbanization. And for 3 years now, the responses that they are getting from these all these executives are really consistent about the most important key trends in the industry. And they are the connectivity and digitalization and electrical vehicles. And also, there's always a question about purchasing criteria, which is both for the consumers, for the customers, and the executives that are providing these products. And it appears that the data privacy and security is the most important criteria for both of them. Which is actually quite a positive result, and it appears that the demands can be satisfied in the market. And I've also wanted to mention some crucial factor in consumers' purchase decision, which is safety innovation. And this is consequently growing interest in this area. And when we would gather all of this information and even more from the industry, we could observe how the evolution of automotive is going. So all these trends like connectivity, like autonomous driving, which is also listed in these questions and the surveys, are the big sources of challenges and growing complexity in the cars. And they have just one thing in common, which is obviously safety. And coming to that complexity, so with more technologies, with new technology that are adding more and more software to the product development cycle, this complexity of electronic and or electrical system is growing rapidly. And this is the point where the safety of cars or safety of the environment is at risk because of increasing amount of data, of integration of much more components into one system. We are also using external devices which are not vehicle specific, for example, like our smartphones. And we, even by using that, we are putting the cars at the risk of malfunctioning. So this diagram represents how, in terms of time, the car functions are changing. And we can see some important innovations like CAN buses being introduced by Bosch company, for example, in 87 or 86, I think it was the first CAN bus created. And it was a huge breakthrough for the industry, or the ABS 10 years before. But I want to focus on the ECUs here. Oh, sorry. Yeah, there it goes. On the ECUs that are increasing, the number of them in the cars are increasing amazingly quickly. So in 1996, we can see that we have around 10 ECUs in the cars. And in 2010, it's around 70. So only 15 years, and this is the growth we see. And now in 2020, we can say that it's even up to 150 ECUs in the most luxurious cars. So this is a lot. And with so many systems and so many components that we want to connect with each other, and they are provided by different suppliers in the industry, it's really a challenge to control every signal and every possible interference. But at the same time, we know we need to realize that small failure in our systems can lead to fatal consequences in the end. So safety is something that we not only should think about, but we have to treat it as a must if we wish to continue develop. Okay, and obviously there's a matter of marketing at some point, and original equipment manufacturers, so OEMs, want to differentiate themselves in market, and they're using safety as a key selling point. So I've put an old car ad on the left from late 30s that highlights safety matters, and we can see the big heading on the top that says safety interior. And that's right, at the moment there was the safety was meant mainly by all steel bodies, which is also mentioned in this ad above, and maybe hydraulic brakes. But this was actually the first time that the manufacturer promoted aerodynamic design for safety instead of styling, because still there were no example. There were, for example, no seat belts included in cars, even though they were already invented and used in different industries already. But during during the 30s, for example, manufacturers realized that customers are rather preferring stylish cars than safe ones. So sometimes it was even happening that the windows were reducing the visibility of drivers instead, just not to compromise the design. So this ad is quite odd in that. In the shade of that. And I found some interesting set of how the topic of car advertisement was changing for the years. And basing on the US examples, we can say that from 60s to 80s, the manufacturer emphasized only horsepower, speed, fun that were like the most significant factors for the customers at the time. But not until 1990s that the safety became started to become part of a narrative in the marketing of automotive. And right now it's really hard to find the car advertisement where safety is not mentioned at all. So this is how we change our perspective and priorities, and also what the technology can easily providing us right now, because it wasn't available at the these years. Okay, so but focusing on the modern advertisement, I've provided here Chevrolet and Volvo ad. This year, Chevrolet's mainly based on the safety matter with slogan, "We don't just take safety seriously, we take it personally." So the whole video they made, it's treating about safety matters as the crucial issue and the most important purchasing factor. So we see how the things are changing. And I've also put a screenshot of Volvo website. They have the separate section that concentrates only on the safety matters. And there is one important thing, because we realize that the malfunction of the car can obviously cause an accident, right? With people that can be seriously injured or even dead sometimes. And every case of that is a huge problem for manufacturer, as the brand reputation can be lost. And there was a very unfortunate example of that, which was the case of Toyota Camry from 2007, where in the end, over 9 million cars were recalled. So they were returned back to the manufacturer to exchange some parts or update of the software. And in that case, it was parts because of the pedal that got sometimes stuck. And you can imagine that you're driving and you cannot release the pedal. So only what you do, you can't stop and you only accelerate. And this was a real situation that really happened. And there was pretty long investigation, started from 2007, but going for years. And in the end, it was revealed that the best practices for real-time life-critical software were ignored by Toyota at some point. And in the end, the data was being saved, then overwritten, which implied the unfortunate acceleration. And Toyota had many lawsuits as few people were injured, or rather a few people were dead, but many were injured. And for example, in the United States, Toyota sales dropped like 25% in 1 year. And it was even before the investigation was finished. So before the Toyota's fault was proven. So this is how the market works. And that's why the manufacturers don't want that situation and want to, tends to avoid the liability claims. And in any event of damage, an accident, it's very likely that the manufacturer would have to prove that they've done everything possible that to avoid any mistakes in their product. So, and this can happen only by strictly following the state of the art in our industry. And this is also one of the reasons why manufacturers and suppliers are treating safety issues so seriously. So to sum up this whole introduction, I can tell that safety occupies really a prime spot in the automobile sector today. Now, when we know the background for a little bit, we can move on to the next part, which is safety versus security. And these terms go hand in hand, and they refer to the same goal, but the concepts are a bit different. And in our case, so in automotive, safety is related to protection against hazards coming from the operation of the system itself. But security is about the protection of the system against some external hazards. So it's very clearly stated in German, and I would like to use that. Yeah, it's safety is Betriebssicherheit, which means literally operational security. But security in German is Angriffssicherheit, which is equivalent for attack security. So this is a bit easier in German. And to give you some examples, we talk about safety when systems in car are working correctly and there is no malfunction of the steering wheel, or ECU that controls the airbags is working correctly. But security comes in hand when we are trying to use for example, keyless system and break into the car or obtain our data in the car, our sensitive data about our drive with cyber break-in. So these are, we can easily distinct these two terms, and I hope you can feel this difference. Excuse me. Okay, so what's interesting is that security is kind of a part of implementation of safety requirements. So a particular ECU should not be able to be flashed by some unauthorized software, which is, for example, not provided by the manufacturer, or the diagnostic applications that are able to change the variant of the cars should not be available to everyone and visible to everyone, or they should not be able to reset some diagnostic trouble codes that are present in our cars. Okay, and the types of safety we meet in our industry. We have different types, which is active, passive, and functional safety. And active safety is focused on avoiding accidents or minimization of their effects, if that's really possible. So it can be predictive emergency braking, or when the system starts to break in the critical situation, for example. But in the modern car, we have many systems like that. I'm sure you know them. It can be blind spot detection, or the drowsiness detection of the driver, just to name a few. So they're heavily using all kind of signals, all kind of sensors, radars, lidars, cameras, and more. And passive safety is all about protecting the passenger and driver if a crash occurs, or it can be during the crash. So the accident already happened, but it minimizes the severity of it. So the example would be the supplementary restraint system, which is actually airbags and safety belts system, but with sensors and controllers added to it. And these controllers, for example, are setting the suitable airbag filling level depending on some signals that are received from the sensor. And there is also a functional safety, which is all about risk assessment and mitigation. And functional safety, as according to the official standard definition, is the absence of unreasonable risk due to hazards caused by malfunctioning behavior of EE systems. That basically means that functional safety ensures that all EE systems are working correctly. So taking this perspective, this electric and electronical systems perspective, we can say that passive and active systems can be both functional too. And this is because currently all mechanical systems like airbags or seat belts are supported by software with all the sensors, and there's always a risk of malfunctioning of them. So in that matter, this is the functional safety goal to mitigate these risks. And just to give you an example, we have the feature called blind spot detection, and this is active safety feature. It's preventing the driver to change the lane when the other cars are in the blind spot of our mirror, right? So we check it in the mirror, we see the light usually, and we can say it's an active safety feature because it prevents us from the accident, right? But it's also an electronic system that has some sensors that is sending signals, processing it somehow, and providing the information to the driver in the end. So it's also kind of in the scope of functional safety. But on the other hand, we have safety features called deformation zones. And they are a very specific construction of the car, and they are supposed to take all this all this energy, kinetic energy from the accident in a controlled way. And they work purely mechanically. There are no sensors in there. So this is not a functional safety feature. Okay, yeah. All right. I also wanted to show you how the system that are safe are applied through the world. So this is a very small example, and these are the chosen countries where the legislation of safety systems is applicable. And when you take a closer look, you'll see that in Europe or in USA, we have at least 4 required safety systems in a car, which are really common, like airbags, ABS, a tire pressure monitoring system, or electronic stability control. But on the other hand, we have China, where the only required legislation is ABS. And this data comes from 2017, so they're only 3 years ago, and this is obviously somehow quite disturbing. And we can see the same thing in Mexico, India, or Brazil, but these markets are rapidly changing, and the amount of cars, of vehicles that are in their market are really increasing right now. And together with that, the risk of road fatality is increasing. So therefore, there's the huge demand right now for safety systems in passenger and in commercial vehicles. So that's kind of a fortunate thing. But coming back to the functional safety, I want to spend a bit more time on that. So this is obviously this is an official definition, but functional safety is a concept that can be applicable across different industry sectors. So in our field, it's specifically defined in our safety standard. And we take the formal definition, it's taken straight from the vocabulary section. It says about this unreasonable risk that is caused by malfunctioning behavior. But we already said that when it comes to our systems, our automotive systems, any failure can lead to fatal consequences, even the smallest one. And we know it's not physically possible to create a perfect system without any failures at all. But what functional safety ensures is that any electronic or electrical system fails in a predictable and safe way. So here's the fundamental point of the functional safety concept. It's to create systems which, when fail, and they are sometimes failing, are failing just how we predicted them to. This is the main concept. So we have to prevent the risk in the situation where it would be still possible to happen, and we want to make the consequences less severe for the environment and participant inside. So just to give you more overview to understand the functional safety, here is the perfect example I found in one of the articles. And there's this rule that the safest train is the one which never leaves the station, right? The whole point of that is that what I already mentioned before, so that we can never reduce the risk to zero. And there are two ways to reduce risk. It can be reliability engineering or via functional safety engineering. And the example that catches the differences between them is based on the hardware, on the motor winding that may sometimes overheat and cause some hazard. And reliability engineering would be the design of the winding to be more resilient to over temperature conditions. So there's different design, right? But functional safety engineering would be working in a way that it would add some extra sensor, some temperature sensor, which would detect this over temperature and then switch off the motor. So this is a huge difference, and that's how the functional safety is working. Yeah, so the goal is to fail in a predictable and safe manner. This is the most important thing. And I also would like to show you the examples of different functions that are in the cars and that are related somehow to functional safety. So we have here the battery management, we have seat control, interior lighting, and much more. And we cannot allow for the situations where, for example, during driving, the windshields can't work and there's a huge rain and we are on a highway, for example, or that both of our lights, front lights are not working and there's no backup system. So each of these functions should be treated accordingly with specific safety standards to achieve the most reliable and the most safe system. So if you have any experience in some big automotive project where there are many suppliers that are cooperating to create one product, you may already know that all the systems are requiring, that are related to safety, are requiring additional verification levels. They're requiring more people being involved in them. And then these features, these functionalities depends on the data from different components. So this obviously increases the complexity of the design and in the end the amount of tests and obviously the reviews of each work products. And this complexity and these safety issues that I mentioned, they were constantly coming up in all the discussions and these are the reasons why the industry literally grouped together and something was starting to happen in the industry. So 2 years ago, the Vice President of General Motors, Ken Kelzer, he was the keynote speaker in the Conference of Society Automotive Engineers. And he said, as we look toward the future challenges of new technologies, it is critical that we are unified in the development and application of standards. And this is exactly what the group of these manufacturers, suppliers, and all involved parties in the industry must have kept in mind when a few years later, they decided to start to work on this standardization of our automotive processes and all the requirements that are related to safety. So they wanted to create a unifying safety standard and just keep all automotive electrical or electronic safety-related systems together in a consistent way. And in general, they wanted to make life safer, we can say. So the automotive industry, yeah, there are. So the automotive industry have addressed this whole complexity that was growing, that I mentioned before in the beginning, this increase of functions of data by adapting the existing standard to the automotive industry in the form of ISO 26262. So yeah, so they made a group, they unified standards, and they put it in the one official ISO 26262 document. And it was derived from IEC standard 61508. And this is a very general functional safety standard for all electrical or electronic systems, which was the solution for increasing requirements that have been arriving in years during the development and operation of these systems. But this was not for automotive specifically. It was for many industries like railway, medical devices, oil and gas industry, and more. And the first edition was released in 1998. And with this standard in the market, there were some established procedures which should be applied to all the industries which didn't have their own standard. And this was the case for our industry, automotive, for over 10 years. But because it didn't cover the specific requirements of the industry, we had created a new standard. And what is not covered by the IEC norm is, for example, that during the phase of specific hazard analysis and risk assessment, the IEC doesn't provide doesn't consider the controllability of the driver, so how the driver is able to prevent the fatal consequences, for example, because it wasn't used in oil and gas industry or in different areas. So they didn't also include the problem of supply chain, which is very common in automotive, but not for the other industries. So all these standards were defining practices, procedures, and measures for good quality development and operation, for safe development and operation. But that is also why we wanted to make something specific. And this is the typical supply chain that you can see on the left. This is typical supply chain in our automotive industry. So there is some manufacturer like Volvo, which has the powertrain providers and braking system providers. These providers have their own providers, and more and more. Okay, and coming back to or focusing on ISO 26162, we have two versions of this standard so far. The first one was published in 2011, and the current one is from 2018. And this document consists now of 12 parts, which is almost 750 pages together. And what it gives us, it provides the whole automotive safety lifecycle. So from the management, concept phase, development, production, operation, in the end, it's the commissioning. It used to be defined at first only for passenger cars, but the last version extended it to all passenger cars, commercial ones like buses, trucks, two wheels, motorcycles. And right now it covers, well, it will really cover only electronic, not hydraulic or mechanical systems. And the unique electronic systems, like for special purposes, like for drivers with disabilities, are not in the scope of this standard. Also, there are the hazards like electric shock or fire, which are not addressed in this standard, unless it's the this is coming from some system, electrical system malfunction. So, yeah, this standard is also not a part of a law. So we cannot say it's formally required by the law, but it satisfies this general regulatory principle that says that vehicle safety should be designed in line with the current state of the science and technology that's known. So we can say it's the state of the art in our automotive industry. And it actually means that if manufacturers like Opel or Volvo has the ISO compliance approval, they can avoid the liability claims. As they've done, they evidently have done what was possible for the current state of the art. And in the end, from this regulatory point of view, the standard ISO is currently considered like the best practice and is legally highly relevant. That's why all the manufacturers are relating to it and keeping it as really significant document. I would also would like to underline that this ISO compliance does not guarantee an absolute safe product. We need to always remember, I also mentioned it before, that this with every technology products, like cars obviously are, there's always some risks possible. Okay, so we got to the heart of what our standard consists of. And I think this is the hardest, the toughest slide in this whole webinar. So you guys turn on your focus and we can start. So this is the process. We take a car. This is a very nice one. And in the case, we analyze each electrical or electronic system, and we're checking what could possibly go wrong and how it could happen. And these questions are resulting in definition of hazards and definition of hazardous events. This is called the hazard analysis. And hazard would be like front light stopped working in the middle of the night when we were driving 50 kilometers per hour. And the hazardous event would be like the bulb has run out. It happened because the bulb has run out and we don't have any backup system. So now we identified the hazards and hazardous events. We made this hazard analysis, and now our challenge is to estimate how bad it would be if something goes wrong. And this is called risk assessment. And when we have this phase, we can classify every hazardous event with the specific automotive safety integrity level. So now our task is to classify these events we identified before with some specific ASIL levels. So basically we can say that this risk assessment phase is looking on every part of hardware or software in our system and looking at it from the perspective of the risk, from the risk point of view. And these ASIL levels are based on 3 parameters that we specify for each hazardous event. First one is severity, which means how severe this event would be for the environment or the passenger or the driver. The second one would be exposure, which means how much exposed the driver or the passengers or the environment is to any hazard that can be that was defined before. And the last thing would be controllability, and this is how the passenger or the driver can influence the system to change an impact of the hazard. And the standard provides the specific classes for each of these parameters. So for controllability, we have C1 to C3. For exposure, we have 4 classes, and severity 2. So the C1 class can mean that it's that this hazard can be controllable in general, this event, or C3 meaning that it's really not controllable at all, or it's very difficult to control. E1 can be very low probability of being exposed to this hazard, but E4 means high probability. So we define for each of these events, we define these parameters, these 3 parameters. And based on that, we are using this table, which is provided by the standard, by ASIL standard, to classify it into the appropriate ASIL level. So you can see it's quite easy when we have defined these parameters before. And the ASIL levels are starting from the QM, which is the lowest risky level, to D, which is the highest, the most hazardous event. So just to be specific, QM is not the part of our functional safety standard. It requires only like a common quality processes that should be implemented in this development, in this part of the development of the product. From ASIL A to D, we are required to use this standard. Okay, coming back to the main slide. So this whole analysis, this hazard analysis and risk assessment together, this is a very crucial point of the whole process described in our standard, and it's called sometimes HARA. And at that moment, when we finish that, we should also have the safety goals specified. So we defined the safety goals to achieve some necessary risk reduction. We want to mitigate these risks that we identified before, and we are using to that our safety goals. So the example in our case would be that the lights are working, but if they are not working, we have some backup system of lights for lights that is independent from the first one. So this is the way that we can mitigate the risk of bulbs not working in the middle of the night, right? Okay, and so now we have identified these hazards, the situation, the events, how does it happen? Then we have the risk assessment, how risky these are. Then we have safety goals. So what should we do to mitigate these? And based on all of that, we can create a functional safety concept. And this is the concept that is telling us what should system do. And this is usually independent from the implementation and provided by the manufacturer. And when we have the functional safety concept, this is like a group of main safety requirements for the defined product. And basing on that, we can start to work on technical safety concept, which actually answers the question of how it should be done. So it can already, it is more detailed. It can already allocate the certain safety requirements to some hardware or software parts. And the purpose of that is to specify, to realize the functional safety concept. And usually the technical safety concept is created by the suppliers, by the tier 1. And just to give you more understanding of this concept, I will tell you the small example of airbag system. So when airbags activate at the wrong time, you can imagine that we are driving and they are popping up in our faces when we are speeding, like on it may be even 50 kilometers per hour. It's a serious risk of injury because we cannot control the situation. We can't see anything. And this is where, for example, our controllability parameter is starting to really matter. But this is a condition which we typically can categorize as ASIL, for example, so the highest risk. And the challenge now is to define this functional safety concept for these events. So when we answer the question, how to satisfy the safety goals to mitigate these risks, we want to, for example, for the airbag example, obviously, we want to choose to implement some extra sensor, some independent sensor, and some extra processing chain, which will be activating the airbag only if both these sensors, independent sensors, are giving us the same responses. Or we can add some self-diagnostics to these sensors, so they're checking each other constantly. And this is the way we can create a safe mechanisms and safe features. And this is so challenging. You can imagine that, because when we have ASILs classified, when we said how risky it was, this is really hard to put it to the real safety requirements, and later even to use this whole engineering knowledge to create technical safety concepts and create a system that can really support these safety requirements. And this is also hard for in automotive industry, because we have this supply chain I showed you before, and there are many parties involved in the projects, many suppliers from different countries, and sometimes they need to cooperate really closely to achieve the safety goals set in the beginning. Okay, so here's another survey I wanted to show you. This is a survey that was provided 2 years ago, not 2 years ago, but only 2 years after the first version of our standard was published, so in 2014. And they asked 600 people which were involved in automotive related companies, which were manufacturers, some tiers, consultancy companies, and more. And they received received the responses. They created some kind of summary. I don't want to go into every detail, especially because I don't really agree with some of the responses. Like, for example, on the top level, top left part, when they ask if what's the level of implementation of this standard, and I just reminding you, it's 2 years after the release of the standard. So 20% said that it was fully implemented, and 44% that it's mostly implemented. But in other articles, I've read that even 3 years after the release, they are still like trying to figure out what's this standard about, and that many engineering companies, sensor designing companies or manufacturers were still trying to understand the recommendations and requirements provided by the standards. So don't be naive. It's not possible to implement fully this standard in 2 years, especially when it was totally new on the market. But coming back, I want to focus on this one part here. This is the question about the ASIL. What is the highest ASIL in your company that you are dealing with? And there's this quote underneath that says, "Made us think more about human factors." That may seem quite weird at first, because how can someone not think about people's safety, people's life when designing car systems? But when you are a part of a huge group, when you're working on the part of one function, and these functions in the cars are hundreds of them, and you are losing this focus, and you're just seeing this small part of code that you're responsible for, or the test you have to provide for some function, right? So you don't perceive it as a real component in a real car. You just see some software, some code you wrote, some requirements to write, and that's all. But this is really important point here, that we need to underline, that if ISO standard is helpful only, or at least in reminding people about this human factor, I think it's really necessary and it's really worth it, just to giving people this holistic perspective they can easily use during a normal work. So this is important thing. And the other one is, I found here is the quote that says, the standard is relationship between manufacturer and suppliers regarding functional safety. And this is what I already mentioned, that this is a crucial matter that is also like strengthened by the experts, that we need to have the definitive supply chain. We need to have the close cooperation between different organizations in the automotive industry. And the last but not least was the quote in here that says that ISO 26262 was mainly requested by the customer. And this is the fact that in recent years, the close cooperation with such companies like Toyota, Daimler, BMW is almost not possible without the appropriate functional safety processes implemented already in the supplier company. So what are the ISO effects on our industry? The first thing would be collaboration factor. So it's really expected that the OEMs will use the compliance or certification of ISO to qualify components and potential suppliers of these components. So it says that we are reliable, we are understanding the processes, we have skills to use during like set of skills that we can use during the development of the product. And just to underline the differences between compliance and certification, the ISO compliance means that, the ISO compliance means that the company is compliant to ISO standard, but is this is basing on some internal assessment, and that's all. But ISO certification means that there was this external company that provided audit. This company is independent organization, and therefore ISO compliance is formally confirmed. So there are two different things. But of course, ISO certification means more costs, more preparation sometimes. This is usually the case for the bigger companies. And there is also this effect in state of the art. So in any bad case, the company can provide that they are ISO compliant or is ISO certified, and the system was designed, it was developed, and in the end manufactured in all of these state of the art methods. It's also it like appeared in many articles that it's not so easy for the organization to use this standard, to fully comply with it, and to understand it sufficiently. So many experts are saying that they advise these companies, these automotive companies from development area, and they are saying that one problem is that they don't have enough resources, they don't have enough competence in the areas that are needed for these complex safety issues. There's also the relationship, this close cooperation between different organizations. I think it's great achievement of the standard that these relationships are supported and enhanced. So right now, in current days, you cannot just create a separate sensor which is perfectly working alone, because the integration, the dependency is really important in the end, in the whole product. And there is the case of documentation, which is also quite important, I would say, because many people say they associate the implementation of the safety standards to the formalism, to many theory, not needed, some extensive documentation, which is not necessary in their opinion. But just one thing that we have to keep in mind with that is that this is the evidence for the manufacturer, for the supplier, if something goes wrong. So this is just as important. And I also found an interesting parallel between, in one of the articles, between functional safety and quality terms. So functional safety, or rather quality, could be defined as something that missing of it annoys, but functional safety can be referred to as missing of it hurts. So this is a huge difference. Okay, and we didn't mention these terms yet: the ASPICE, the AUTOSAR, the safety culture. I know that we can create a new webinar out of these terms. They're so broad. We can discuss them each in different webinar, but right now I just wanted to mention them because I think they're like the integral part of safety at some point. And just to brighten the idea of them, I want to discuss shortly each of them. So AUTOSAR goes for Automotive Open System Architecture, and this is created by the group of companies from automotive industry, like manufacturers, again, software providers, and this is mostly popular in Europe right now. And the goal of AUTOSAR is to standardize the software architecture of all electronic control units in the car. So this is what AUTOSAR and safety have in common. So they want some standardization, right? And AUTOSAR help to meet these requirements of safety and these recommendations that are provided in the ISO standard. Because, for example, it keeps hardware and software independent of each other. The AUTOSAR enhances the reuse of software, and it's proven that already working software is safer than the newer one. The interfaces are standardized. More software specifically, we can say that there are these methods like program flow monitoring, for example, when we check the sequences of operations in the system. So all of that supports safety requirements. And there's also this concept called safety culture, which is one of the key elements of overall safety management in our road vehicles standard. And in general, the safety culture wants that the organization is providing like the good, proper environment for people involved in safety activities. So it's enhancing this awareness of safety in all of the processes, is providing a good and very clear flow of information and many more. And I also wanted to tell you a few words about Automotive SPICE, which is a model that bases on the standard ISO 33002. And ASPICE is short for Automotive Software Performance Improvement and Capability Determination. And it helps us assess and understand if the given company is creating software with good quality. It can answer some questions about the quality of the development process, like how to assess the processes that this company is performing, in which they are not compliant with the model. Are these processes enough for the specific product development? And the idea behind ASPICE and ISO 26 are a bit different. So just to give you the examples why of the differences between these two terms. So ISO is considered only for safety relevant issues, right? We deal only with safety relevant functionalities. But ASPICE can be applied to every system that is provided by the software development. In general, ASPICE project is kind of a first framework for the ISO compliance of this project. So when we are ASPICE compliant, it's some kind of a first stage, but it's not enough to be ISO compliant. These are two different things. And in the end, a few words about SOFTIF. And maybe you've heard about it already or not. It's a standard for road vehicles, just like 26262, but they are focusing on the safety of intended functionality or function. And when we simplify this, the whole idea that comes behind that, it means that 26262 is covering safety if there is any failure in a system, but 21448 is covering safety without system failure. And therefore we can say that SOTIF is more general or has a greater perspective. And the ISO 21448 was originally intended to be part of our functional safety standard, but it appeared to be so complex and complicated because you can imagine that in ensuring safety in situations where there is no system failure, but just the design needs to be safe, is quite a challenge. So they decided to make a standard of its own. And currently, it's not like official standard. It's called PAS status, which goes for publicly available specifications. And it's currently in the international working groups reviews. And after this phase, it will be replaced by the official standard, ISO standard, in the same number. So the SOTIF could be applied to, for example, critical features that are developing the machine learning, the artificial intelligence, and these features in cars are, for example, advanced driver assistance systems called ADAS, or some emergency intervention systems, some intelligent lane systems, and more. Okay. I wanted to tell you a bit more about functional safety that meets Agile, but the webinar appeared to be so long that I decided to cut it and use another webinar to focus on that topic. So sorry, guys, about that. And moving forward to the conclusions, here are a few important things I like to just stress out in the end. So first is the automotive concept of functional safety. So it doesn't mean that there is no risk or there is no malfunction in the car, but it means that there is no unacceptable risk. We want to know these risks and we want to predict how the systems are failing, right? And also by implementing ISO requirements, we realize that we need to realize that this is a very complex process. It can be overwhelming for many companies, as safety doesn't evolve overnight, right? And it's achievable because companies are committed to deepen their knowledge. They want to get more competences. They want to cooperate to get better results, to get better products, and they see many advantages of it. We need to realize also that many failures are leading to the bad consequences, to fatal consequences to people, cars, or environment, and it could be prevented if we implement the safety requirements correctly, if we implement them at all sometimes in some cases. So the goal of this standard is to create safer road environment for every participant of this environment. And also the company sometimes want to limit functional safety processes because they feel like it costs too much. And yeah, it says that it may be about 30% of the project costs at some for some cases. But when we are avoiding the crucial safety processes, it can also lead to higher costs because of the reputation being lost, because of the lawsuits that we get, like Toyota case. So, so that's quite important thing to improve and to provide this safety processes. And in the end, I would say that for all areas in the projects, the challenge is just to keep the practice. So to keep this long term, to keep this consistent deployment of these good practices when developing the product. This is the most important, to constantly growing and to keep these good processes for in every phase. And in conclusion, we can say that I don't want to think. I don't want you to think that ISO is like a formal burden or like an extra documentation that I mentioned before. I think we need to perceive it as a culture that influences like every single organizational layer, from the management to the single engineer in the end, and that it impacts every stage of the product development cycle. So yeah, next time when you will drive a car, I just want you to think how much effort people are putting into making this product. And it may seem that sometimes something is not working well. We thought about that too. Okay, and here are some links that I want you to wanted to give you that I think they're worth visiting. Some great articles, some good webinars, also about functional safety, about safety matters at all, and more. Yeah, and here are the sources. And thank you. Thank you very much for listening to me. Veronica, are you there?
Yes, we have one question that appeared. Please check, Jurata.
All right. Okay, how to combine ASIL classification with hazard rate in automotive market in accordance to ISO? What types of hazard analysis can we use to calculate hazard rate in accordance to ISO 26262? How to combine, I don't really understand this question. How to combine ASIL classification with hazard rate. I think, okay. So do you mean that, you can raise a hand, by the way, so we can discuss, but yeah, so GlobalLogic wants to, okay. So how to, what does it actually mean that ASIL D is risky, right? This is what you ask? Is there someone else? Is there someone who asked this question in here? Not really.
Hi, Bartłomiej
Hi.
from this side. I have question about, you present a really nice presentation about ASIL, and I have question how we analyze hazard rate in according to ASIL classification. We must analyze or prepare at the beginning hazard analysis like FTA of FMA to analyze some faults or hazards, and how these results of this analysis are combined with ASIL classification.
So that's what the parameters are for, right? For each parameter, we have different classes, different scale, and the standard provides a few examples for each of the parameters. So you can try to understand what's your case in the light of the other examples. And when you have this controllability, severe, and exposure, you just take whatever you defined before, and you try to choose the right class. Of course, there are a lot of problems because you can say that it's not very specific. What does it mean to be controllable or to be a little bit less controllable, right? But this is why the standard is, it cannot give you the specific answer because of too many features that can be assessed by this standard. And this is also a good question because some experts are saying that in the articles I wrote that this is a hard part of the this ISO compliance. They don't know how to specifically and very precisely assess how risky is this event and how to set the appropriate level of controllability or of severity, because 4 or 3 levels or classes of that doesn't seem to be enough. But I can't tell you more about that right now because I've never taken part in the process of assessing that. So yeah, sorry. I hope my answer was enough. Yeah. And I saw that there are many answers, right? During this webinar, give any, okay. Not really. You don't have any certificate after this webinar. Okay. If you have any questions, you can easily reach out to me via LinkedIn or via email. So I'm open to any questions later if you will have some. Thank you very much. See you. Bye.